Okay. I believe this is 4.3. I kind of sometimes get muddled on the actual section number, but it is vertex form. That's essentially what we're going to be doing in this section. That is the focus of this section. And so before we get into it, we have seen things like this before. We've seen negative 2x squared plus 6x plus 8. We may have seen this actual entire problem. I wouldn't be very surprised if that was the case. But up to this point, what we have been seeing is, oh, generally when we see this, we factor it. Or I think maybe we did one problem where we might plug in actual points for x and then get a result. And that's all fine and good if we are just looking for intercepts. That's a really great way to find intercepts. Or if we're looking to find a single point on our graph, we can plug in a value for x and get y. But it doesn't really give us a whole big picture of what does our graph look like overall. And so vertex form, what it allows us to do is it allows us to get a very good idea of the shape of the graph, the direction of the graph, and the starting point of the graph. So we have seen a quadratic graph before. It's the x squared. That's the classic one. But if I were to, let's say, have this equation and factor it, I would have essentially no information. I mean, I would have the information that it doesn't have x-intercepts, but I wouldn't be able to know, okay, is it facing up? Is it facing down? Where is the starting point? So we call that bottom point the vertex, and we label that as h comma k. Apologies, I'm not actually using my pen. I'm using my mouse, which is a lot harder to write on. Okay. Does anyone know what vertex form is? Kind of the general form for that.
F of x equals a times x minus h squared plus k.
Perfect. And so kind of referring back to the picture, if we can get something into this form, into this equation form, kind of similar to the value of slope-intercept form, well, then we can just kind of take the information and say, oh, I know my h value of my vertex, I know my k value of my vertex, and in fact, I also know, based on what we were doing with transformations, I know if it's a stretch or a shrink, or if I'm being reflected in any direction, so on and so forth. So for starters, we want to just get this guy into vertex form. Again, maybe someone who has watched the video, what is my first step when taking something and we call this standard form, or I think general form if we're, yeah, I think this is general form. What do I do if I take something in general form? How do I get it into vertex form? So we start by finding our h as a bit of a refresher. So how do I find my h?
Do h equals negative b over 2a.
Perfect. What's my b? What's my a?
Six and negative 2.
Yep. So this is also something we've seen, albeit it's probably been a little bit, I'll annotate. That this, when we write a quadratic, we have an A, a B, and a C. So this is my A, this is my B, and truth be told, as far as vertex form goes, the C is not super important. So that's where those values are coming from. Negative B over 2A gets me negative 2 over 6. No, wait, I flipped that. Yeah, 6 over negative 2. And so negative times a negative gets me a positive. So this is really the same thing as 6 over 2, which is equal to 3. Everyone clear with that? Okay.
So you're not multiplying a times 2?
Yeah. Oh, yeah. Thank you. Oh no, I'm going to have a fraction. Oh well. We'll be able to power through it. Thanks for that. Yes. Flipping, I'm dropping 2s. It's good practice for you guys to know what mistakes not to do. Cool. Someone besides Courtney, how do I find K?
You plug in 3/4 into the function.
Yeah. So I take my original function here and I plug in my h value. You say K is equal to f of x or f of h, which now we know what the h is. It's actually that 3/4. Oh boy, wrong copy. There we go. And then, yeah, now we just evaluate. Let's erase this. Okay. And 3/4 squared. Does anyone know what 3/4 squared is?
Nine 16th.
How'd you get that?
You're just multiplying the 3 by 3 and then 4 by 4 on the bottom. So I guess do the numerator and the denominator separately.
Yeah. So when we're squaring a fraction, sometimes you say, oh, okay, I don't know how to square fractions. That's kind of scary. Well, it's actually not too bad. You can square the top, square the bottom, and then you'll get your final answer. So 3 squared is 9. 4 squared is 16. Plus space here. Get rid of this square here. Ooh, and then I multiply the first fraction by -2 on the top and bottom. I get -18. Oh, 16 plus 6 times 3 gets me 18 over 4 plus 8. Maybe I'll shortcut this and kind of use my calculator to cheat. Losing the trees for the forest or whatever that statement is. So that gets me a final answer, 11.375, or if we want to write it as a fraction, 91 over 8. Oof, should have picked an example that is not a fraction.
I have a question.
Sure.
Back on the when it was h equals, if it was 6 over 4, how did that turn to 3 over 4?
Oh my goodness. You're right. Shoot, do I really want to do this whole thing over? I'm going to scrap this problem. We're getting lost. Let's make it easier. Let's take away the 2. Okay, reset. That make it easier. Yes, cool. So hopefully with this will be less terrifying. So same thing, I'll run through it a little bit more quickly. The negative, or B in this case is still 6. The A is 2 or -1. Then that gets me 6/2, which gets me 3. Whole number. Awesome. Okay. And the same process for my K. Which is equal to this with a 3 plugged in. So that gets me -9. Make sure it's a good idea to put the first number in parentheses so you don't think you're squaring a -3. You're squaring a 3 that has a negative in front of it. Then 6 times 3 is 18. And so I get 9 plus 17. Okay, much better. Good. Feel like Josue should be our quality assurance person because he's catching a lot of my mess ups, but I think we're good here. Cool. Everyone feeling better about this now? Hopefully now that we don't have spooky fractions flying around. Okay, so when we're asked to find the vertex, well, we've actually found it. We know our vertex is going to be our, as we saw in that picture, it's our H comma K. And that's exactly what we were just finding. Our H is 3, our K is 17. Boom, vertex found. Everyone good with that? There's my H, there's my K. Great. Now for vertex form, we need 3 pieces of information. We need an H, we need a K. Boom, we have 2 of those things. Great. What we haven't found is this A. We're not going to replace our X permanently because X is a variable. That's our thing that's going to change. But we do need to replace our H, which we know what that is already. We need to replace our K, which we know that what it is already. And I would claim finding A is actually pretty simple. Once you know how to find it, obviously a lot of things aren't simple until you know how to find them. What's my A?
-1.
It is -1. How did you get that?
Looking at the original equation and at ABC.
Yeah, exactly. So finding A is pretty easy if we have an equation in general form. This is my A, this is my B, this is my C. So my A is, well, it can't just be a negative sign. So we have that invisible 1 sitting there. So my A is -1. And you should be able to, as long as it's in general form, always do that. You just go, okay, where's the X squared? What's the number in front of it? Voila, I found my A. So what's my final vertex form going to be?
-1 parentheses X minus 3 squared plus 17.
Now something to note here. Notice how my vertex had a +3 and a +17, and then my vertex form still has a +17, but the 3 changes sign. And that's just because vertex form has that X minus H, or if you want to think about it as a transformation, that's because what's inside the parent function goes opposite. So watch for that. If I have a vertex In my vertex form, the x value or the h value will be swapped. The sign will be swapped, and the k value, the sign stays the same. And if we were to reverse that, we also have to account for that. We'll focus on reversing equations in next class period, but remember that. Watch for that. That's a big place a lot of people lose points on the exam, is you don't flip that h sign. Okay, that was a battle. Are we good with that? Okay, I'm going to give you a lot of time to practice this vertex form, this changing general into vertex form, because that's kind of the heart of this entire section. Is vertex form is cool. That should be the actual title of the section. Gives us a lot of information. So if we can get something to look like vertex form, great. We'll be able to graph it a lot more easily. We'll be able to know the range, the domain. We'll be able to know the maximum point, the minimum point. We get a lot of bang for our buck when we have it in this form. Cool. So the worksheet we should be working on is 4.3 part 1. Okay, it is 4.3. Good. And then you should be able to do the first 6. Number 5 is a repeated question, so you don't really have to do that twice. But the rest of them are good practice for you. Are there any questions before I put you in your breakout rooms? Cool. Okay, so this is a really valuable video to watch, because the nice thing is once I get through the majority of this section, or maybe it's when I've done the entirety of the section, I kind of organize everything into a nice little table. I say, okay, once you get vertex form, you can find the vertex, you can find the A, you can also find the range, you can find the minimum or the maximum. So let me adjust this problem slightly so we don't think we always have a 2, which is dangerous to do on the fly. Negative b over 2a. I think this will work. Okay. So to kind of give it some context with a picture. So if we have a quadratic, again, we can't lose the sight of really the purpose of this section is to focus on the graph of a quadratic or an x squared graph. So when I'm graphing a parabola, there's really 2 possibilities I have as far as orientation goes. I can have a graph like this, facing upwards, or I can have a graph like this, facing downwards. And so the red graph happens when a is greater than 0. And the purple graph happens when a is less than 0. Now, if I'm thinking about maximum or minimum, visually, it's not too terrible to think. If I have an a is greater than 0 graph, my minimum is right here, which, as we might know at this point, that's the vertex. So again, vertex form is great because if I have that, I can tell you if a is greater than 0, the minimum point on my graph. And if a is less than 0, I can find the maximum point on my graph. It's right there. It's the vertex again. So when finding maximum or minimum, we say if a is greater than 0, then we have a minimum. And if you want to write it as a point, I'm fine. You just write it at the vertex. Sometimes people just say the minimum is the k value. I'm fine either way. I would probably write out the point, but no, it's not that hard to extrapolate from that. And if a is less than 0, then I have a max at my vertex. And now notice how in both of these cases, the entire thing rotates around, surprise, surprise, our vertex. I need to find my vertex before I can determine if my graph has a minimum or a maximum. Well, I can actually figure that out by looking at the A, but where my graph has a minimum or a maximum. So again, as practice, we have this function. Let's write that in vertex form. First step. I guess, what is my first step?
H equals negative b over 2a.
And my b is what?
Positive 4.
And my a is what?
Negative 2.
2. And I guess for consistency's sake, it actually doesn't really matter if my negative's in front of my fraction or on top, but I think my video has it on top. So let's just do that. Cool. And so then I have negative 4 over negative 4, which is just 1. Cool, not too bad. Don't have any weird fractions flying around. I find my k.
The f of h function.
Mm-hmm. I find that by just, well, plugging an h into my function, which since it's -1 actually should flow, or a +1 even better, should flow pretty nicely. -2 plus 4 plus 8 will get me 10. We good? Quality assurance look good? No trip ups there? This isn't me like coming at you or anything, for the record. Genuinely, I appreciate when you guys correct me because mistakes are really tough to track down in notes. Okay. So my vertex is what? Oh, it says frowny face.
110.
It is 110. It's my H, it's my K. Okay, so now using this information, does my graph have a maximum or a minimum? And what is the value of my maximum or minimum?
It would have a maximum of 110.
How did you know it was a max versus a min?
Because the A was less than 0.
So we already know in either case, my min or my max is just going to be at my vertex. That's not too terrible. I need to determine what my A is, and my function determine if it's a min or a max. A is -2, so I'm going to use this guy. So this problem, in my opinion, is really just exactly what we were doing on the previous slide, with the added wrinkle of, okay, I need to look at X and say it's a max or it's a min. That's it. There is, if we have a maximum, there is no minimum because it goes, my graph in purple goes all the way to the bottom. And if my graph has a minimum, there is no maximum because my graph goes all the way to infinity. And so that's why we only talk about one or the other. You don't really have to know about the concept behind that, but it's just, for the record, worth stating. Cool. And now I would argue, I think in the worksheet, I separate these into 2 different pieces. I say, okay, find your min max, find your range and domain. They are so related to each other that I figure we can just kind of tack it on into this question. So domain, in fact, domain, you could answer this question based on previous knowledge. You wouldn't even have to know anything we learned today. What's my domain?
Negative infinity to positive infinity.
Yep. How did you know that was your domain?
Looking at the graph, it's going to keep on going both ways on the x-axis.
Perfect. Yeah. So visually, that's a great way to do it. We can look at our graph and say, okay, it's going all the way. Well, I guess it's the purple one. It's going all the way to the left, all the way to the right. Perfect. What about kind of using the domain tricks that we talked about? What case is this problem?
3.
Yeah, it's a case 3. I don't have any fractions. I don't have any square roots flying around. So it's just negative infinity to infinity. I'm fine with either one. But the shortcut is, if we're doing this, if we're in the quadratic realm, domain is an easy question. It's 3 points, just all real numbers or negative infinity to infinity, whatever one you want to write. So cool. That's the easy part. The harder part, which I don't know if it's much harder, is my range. Now, I would also argue you don't really need to know stuff about from this section to answer this question. I mean, obviously you would need vertex form, or I guess more specifically just the vertex. You would need the vertex, but if I gave you the information of what the vertex is and what your A is, I would argue you could find your range very quickly, not really needing a vertex form or not really needing to do a whole lot more math. What's my range of this?
Range is negative infinity to 10.
Steal this guy. Oh, that might not work. Let's just type it out. Negative infinity to 10. How did you get that?
Well, we know our max is at 110, so we know that the graph doesn't go any higher on the y-axis than at 10.
Yeah, great. We can look at the fact that we have a maximum and just logic it out and say, oh, well, if that's the biggest part of my graph and my graph clearly goes all the way down to infinity, good to go. You can also, look at the graph here and see the purple of, oh, it goes all the way up to that point, which is my vertex, and then it goes all the way down. So my range has to be negative infinity to 10. And so the shortcut is, or maybe, I don't know if it's a shortcut, just a way to kind of organize it, is we again have kind of an if case. So if A is greater than 0, my range is going to be bracket K to infinity. Right, yeah, that's right. And if my A is less than 0, like it is in this case, my range is negative infinity to K. Like we had here. That ours was case 2 again, because my A was less than 0. This is what I ended up using. So I would argue that I'm not, or personally, I'm not great at straight up memorizing formulas and knowing where things go immediately. That being said, there are people who are the opposite of that and are really good at formulas. So if you want to kind of have a, oh, strict rules, this is what happens if A is less than 0, this is what happened if A is greater than 0, this is the breakdown of it. You can look at this. These are the 2 cases I'll have for min max. These are the 2 cases that I'll have for range. My domain's always going to be negative infinity to infinity. If you're more of one of those that follows concepts or logic of things, I just always sketch a graph and say, okay, if A is greater than 0, that's going to be the red graph. And now it's not too terrible to think about what my range is and what my max and my min is. But either ways works, whatever one you're more comfortable with. I guess, truth be told, if I had a note card on my test, I would probably write this down as a check. But I as far as just memorizing it, I wouldn't do that. I'm not great at that. Any questions about this? Cool. So let's see, what do we have left on the worksheet? Actually, let's stop my recording.